So now we're going to look at how do we organize the data of a binomial probability experiment. So we organize it in what's called a binomial probability distribution. So if you think of back to frequency distributions, those were a table of all of our information. So for a binomial probability distribution, we will be listing possible values of x with corresponding probabilities for each. So this right here is my definition of what a probability distribution is. And so we are going to do an example right here. So in a survey, workers in the US were asked to name their expected sources of retirement income. The results are shown in the graph. 7 workers participated in the study are randomly selected. So 7 is going to be our total trials. And asked whether they rely on Social Security for retirement income. So do you or do you not? So that goes into it's either a success or it's a failure. So on our little chart here, it says 25%. So that's our probability that we'll be using. Create a binomial probability distribution for the number of workers who respond yes. So yes is our success, 25% probability that they are going to respond yes. 7 is our total. So P is 0.25, N is 7, and then X can be any number from 0 to 7 because X is the probability of success. So we either have 0 people saying yes, we have 1, 2, all the way up to a maximum of 7. Since we only interviewed 7 people, we're not going to have any X values beyond 7. So here I made a little chart to organize our data, and we're going to have to go through and find all of the probabilities for successes from 0 to 7. So we can do that using this calculator. So there are 7 total people. The first one in our chart is 0, and the probability of success is 0.25 because it was 25%. Here, 0.13. So in my chart, 0.13 is for 0, and we're going to go all the way through and do these all the way down to 7. So for 1, you get 0.31. And this is why it's really important to know how to do this either on your graphing calculator or on the computer, because if you were to do this all out by hand, that would be very tedious. So for 2, we get 0.31 again. For 3, we get 0.17. For 4, we get 0.57, so 0.06. For 5, we get 0.01. For 6, we get 0.001. And for 7, we get 0.00006. So that is 4 zeros. 0.00006. So as you can see, when you are lower down here, you have smaller probabilities and then it increases and then it starts to decrease again, and that will typically be what you see in your distribution. Okay, so moving along. So what about the graph of a binomial distribution? So we can graph just like what we found up here. First, you need to create a distribution, and then you can draw it in a graph form rather than a table. So it says example 6, 59% of households in the US subscribe to cable TV. So we know that this percent is going to be used for something. You randomly select 6 households and ask each if they subscribe to cable TV. So subscribing to cable TV, that is our success. Construct a distribution for the random variable x, then graph the distribution. So 59%. So P is 0.59. N equals 6. And our x values go from 0 to 6. Because that is our possible values that will be successes. So the first thing I'm going to do is make my x and p of x column. I have to do exactly what I did in the last example. first before I can graph. So now P is 0.59 and N is 6. So we need to change this. So 6, should I just reset this whole thing? 6 down here, 0.59. And the first one we'll start with a 0. So 0.0047. So 0.005. For 1, we get 0.041. So 0.04. For 2, we get 0.147. So 0.15. For 3, we get 0.8. For number 4, we get 0.305. So 0.31 for number 5. We have 0.175, so 0.18. And for number 6, we get 0.042. So once you have this table, you then want to draw it as a graph. So in a graph, you have an x-axis, you have a y-axis. Your x-axis is going to be your x column, and y is going to be your p of x. So here, this represents households, and this is the probability. So always make sure you label. So for households, we want to label 0 to 6. For probability, we know that it goes, it's all decimals. It's not going to go below 0 beyond 1. In this case, it looks like our highest decimal is 0.31. So can go by 0.1. So 0.05, 0.1, 0.15, 0.2, 0.25, and 0.3 up at the top. So for 0, that goes with 0.005. So that's going to be a little tiny one down here. For 1, it is 0.04, a little bit higher up. For 2, it is 0.15. So that would be 0.15. And I did it a little too far over. Here. For 3, it is 0.28. So 0.28. Whoop. For 4, it is 0.31. So that is our highest. So there's 0.3. It was a little bit more. For 5, it's 0.18. And the last one is 0.04. It's right about there. And you can give a title. So here, subscriptions, do that. We'll do TV, cable as our title.